There's more to the Shenandoah Valley than meets the eye. Beneath Virginia's Virgin Valley Province is a karst topography marked by its calcium-carbonated bedrocks and the sinkholes and cavities that come about from its dissolution. Virginia itself has over 4,000 caves. How do they form? Rainwater falls and seeps through the ground and is either already being slightly acidic or increases in acidity as it passes through decaying organic matter or leaf water coming ground or soil microbes. Some of the now at least slightly acidic water, as well as the carbonic acid, like H2CO3, dissolve the calcium-rich carbonated rocks, including limestone and dolomite, including by converting it into more soluble calcium percarbonate, CaHC3032, and groundwater carries the solution away. Groundwater carries the solution away, leaving behind a cavity. These cavities form most frequently at the top of the groundwater table, at which the depth the calcium carbonated rocks are saturated in the phreatic zone. As the groundwater table changes, different levels in the cavity form. The water table drops, or the water drains to the end of the channel, leaving behind the formerly phreatic cavity, now filled with air and with high humidity, phredos, unsaturated. If the ceiling of the cavity cannot be sufficiently supported by the adjacent rocks that form the cave's walls, then it will collapse in a sinkhole or depression may form at the surface. If the adjacent rock walls can support the ceiling, and if earthquakes do not destabilize them, then the cavity can continue to exist. Some ceiling collapses do not fill the cave, but instead can increase the size and height of the chamber. The cave's temperatures remain consistent year-round, those found in the state at a temperature of 12.2 degrees Celsius. Caves with active streams can grow at a rate of 1 millimeter a year at most. The high humidities in the caves often prevent water from evaporating. If the humidity drops below 100%, then the water can evaporate. Water carrying a dissolved carbonate solution evaporates in the cave, depositing behind calcium carbonate, which can form with the minerals of calcite. These depositions are the basis and origins of many speleothems, or cave formations, found in these caves. Dripstones are cave formations which come about from deposits applied by evaporating water droplets. As water continues to deposit, calcium carbonate soda straws form, which are thin, hollow cylindrical formations which grow from the cave ceiling. If some particle blocks the water's path in the soda straw, it forces the water to leave the depositions not only downwards, but also outwards, leading to the formation and growth of stalactites. If the water does not evaporate before reaching the bottom of the cave, it can leave a deposit on the cave floor, leading to stalagmite formation. Stalactites hang tight to the ceiling, whereas stalagmites might reach the top. If the droplet has a long time to fall, the stalagmite might have a rounded top, because the water does not hit the same spot each time. If the droplet has a shorter fall time, the stalagmite may be sharper, as the droplet is more likely to hit the same spot more frequently. The stalagmite can often form right below the stalactite. Over time, if the two formations meet in the middle, columns form. Sometimes, from the tremors of some earthquakes, stalactites above the cave ceiling may fall, leading to interesting, suspended formations like bells or horizon-lying stalactites. In this place, stalactites do not grow further, instead, other formations may grow from them. Flowstone is another type of cave formation, which comes about as flowing water evaporates and leaves behind a smooth-looking deposit. Some hanging flowstones from hanging formations called draperies, as well as so-called cave bacon. These formations grow slowly at a rate of around 1 centimeter every 100 years most, and their prolonged growth depends on a continued source of seeping water and the surface from which the water evaporates. Do not touch cave formations. The oils on our skins interfere with the water, which is essential to their growth, and can even alter their color. For example, after tourists were allowed to touch the so-called fried eggs formation of Rory Caverns, the previously yellow-colored stalagmite, the yolk, paled. In the skyline caverns, there is a single cave formation which tourists are allowed to touch, whose surface is visibly altered from that of the naturally untouched cave formation. Pure calcite is white in color. Reds and oranges come from iron, greens and blues from copper, blacks and grays from manganese, but some greens are also from plants, which can only exist if spores are brought in by people and there's sufficient light, like that from lamps in show caves. In dry caves, water no longer supplies the cave formations to grow. In wet caves, water continues to seep and drip into and through the cave, and so its formations can continue to form and grow. Some cave streams are fed with surface water, others with groundwater or both. Cave streams fed by surface water may lead to the odd surface animal being swept in, like snakes, fishes, amphibians, and insects. Caves whose streams are fed by surface water may also experience flooding during extreme downpour, such as during prolonged storms and hurricanes. With negligible wind in many ocean caves, some cave pools have a still mirror-like surface. The waters of some shell caves' cave pools are tainted in color and made up by the mineral and metals found in coins and money, especially if used as ocean wells. In some cave pools, a thin film of deposited crystals line the surface as though a sheet of ice. Sometimes, water falling out of the caves is so saturated enough with calcium solution to deposit it further downstream. Travertine, a type of limestone, is deposited by surface streams, as seen here at North Bridge State Park. Some theorize that the large 66 meter tall and 27 meter wide arch that is Lateral Bridge is the remnant of an ancient cave roof. The ecosystem within a cave is obviously very different from that of the surface. In some, guano, deposited by bats, bring surface nutrients into the cave. In others, minerals and nutrients present or carried in by cave waters can be the basis of some ecosystems. Some cave species do not depend on the caves but use the caves for shelter, like bats, troglophiles. Others depend on the caves, troglobites. The uniqueness and isolated nature of many cave systems mean that some species found in certain caves are found nowhere else, like the Dixie Cave salamander, Python Dixie. The relatively hard-to-access nature of most caves also means that there is so much to discover for those willing and able. Beside the awe-inspiring intrusions of flowstones common in many caves, there is also a much rarer cave formation, the bizarre and tintite.